software does automatically once the 3D model of the product is integrated with it. This is applied to a face mask in the PPE industry, which I have my version for me right there. But we'll see later on how our software can be applied on different industry and other products, such as the product in the orthotics and prosthetic industry and sport equipment as well. Oops, I'm just gonna lower the sound. All right, so we can integrate in just the scan. We can find the landmarks, do automated symmetrization of the face, do some scan processing, scan rectification. All of these steps in this process are fully automated. There's no manual interaction. There's no human involved in this process. And what you end up with is with a mask that is custom fitted to the person and that respect different engineering and design requirements. And of course, it fits. And we'll see later on the different various challenges related to this product. But first, maybe you have some question. Does this technology apply specifically to my business? Do I really need it? Who else uses it? And I think most of the wearable industry will follow the same path as the dental industry did years ago. The dental industry transitioned from prosthetics done manually in the lab using plaster and without any software to being a digital, fast-growing industry. And now you can see implants, surgical guide following the same footstep and really growing to be mature industry. And what we found out is usually as market evolved, they follow those steps. They started with standard sizes. Then you can see expensive customization process going on using mostly craftsmanship. Then there's a transition to a more efficient process using digital tools. And then the price goes down, which enabled the deployment to the mass market. And we believe that the next two markets to mature will be the orthotics and prosthetic market and the protective sport equipment. And we know orthotics and prosthetics will be the next one because 100% of growing medium to large size clinics group, central fab, and manufacturers have an R&D program currently in 3D printed orthotics. It's not just buzz. People are actively investing in that technology. They're actively researching it. It's not visible sometimes, but everybody's working on it at the moment. Also, you see more and more in the news brands like CCM and Schutt and Vices working on 3D printed custom protective sport equipment. And that's just another market that we'll see more and more being applied to the real world. So how does it work? And how do we fit in the value chain to complete our digital transformation to our 3D printed custom product? In a nutshell, the whole process can be described in three words: scanning, fitting, and printing, or simply scan, fit, print. There are plenty of solutions on the market for each of the steps of the process. You have a lot of scanning apps that are either designed for self-use or to be scanned by a third person like a clinician. There are also many customization software out there. And there's many 3D printing bureaus and 3D printing manufacturers to choose from in your geographic area. We do provide a turnkey solution to our network of partners, so you can choose a solution that best fits your need at every step of the way, and we integrate and streamline the whole process. If we focus now on the fitting itself, we can see three approaches currently done in the market. There's a twin approach, which is to manufacture an identical, tangible replica of the body part on which you're going to build using traditional method the final product. You can either carve that product, that digital twin approach, that twin, or you can 3D print it. Then there's the augment approach, which is basically starting from the scan itself and kind of building it out, building the product out using like drawing or sculpting or different digital methodology that you kind of basically build out the product on top of the scan. And then there's a custom fit CAD approach, which we believe is the most advanced one. It allows you to have, hinges, complex systems such as hinges, multi-material assembly, differentiating patterns, and you can have a lot of advanced feature like a BOA system, for example. ShapeShift 3 does use the custom CAD approach, but we, instead of using nerve surfaces, we morph pre-existing template to overcome the limitation of current CAD software, such as the lack of robustness and the lack of user-friendliness. and you end up with a very solid approach. So Shapeshift 3D, the Shapeshift 3D platform allows a precise and compliant fit every time. It does a seamless integration from the 3D scanning and the 3D printing technology. Respect the different product design and engineering intent of the product. What I mean by design intent is, of course, on different person, the same product should look the same. It should have the same brand, the same aesthetics that really allows a company to build a brand out of this product, even if they are customized. And they need to respect their engineering intent. So, for example, the mask has a filter cartridge, which is produced with molding. When we're going to insert it into the mask, even though the mask is custom fit, it has to line up perfectly. It has to create a seal. That's one of the engineering constraints we can respect. And in terms of the assembly process, you can have different parts. In this mask, for example, there are 2 3D printed parts, and there's one silicone liner that is water jet cut. And the silicone liner will get sandwiched between 2 parts that are closely mating one another in order to create the perfect seal. Those kind of feature would take hours or even like a week to customize such a complex model on just one individual. We do it in minutes. And that is possible thanks to your uniquely patented technology that really allows to customize product at scale, which we call constraint template morphing. And then the next step that we did is we complemented the constraint template morphing with AI to really replace the tedious work and give orthotics and prosthetics control where it really, really matters, not on the tedious tasks. I'm going to show you another example of a semi-automated process. In this process, the user has to click on 4 points, and then every later step is fully automated until you end up with a last that can be used to create a speed skate that is used by Olympics athletes. We also do scan processing of the leg based on various information. We can orient the leg. We can extract the useful part of the scan on which we want to build the product. These kind of tedious tasks can take minutes, tens of minutes to a customer, to a technician, and we try to replace those tedious tasks, which really doesn't bring more value, and make sure that the clinician focuses effort on creating a better product for the customer, for the consumer. We do various body parts, like I said previously, from the end, the face, the ankle, the head. We've worked on multiple body parts so far. Always in mind to respect the design intent, engineering intent of the product, and automate the tedious tasks. So in a nutshell, this is how we do the customization process work. We have the scan as an input. We do automatic landmark recognition where the technician, the clinician, the orthotist prosthetic can do modification. There's also some rectification step that can be applied. Then we place the device on it, and then we export the model, and their model is respecting the design intent, engineering intent, thicknesses, assembly constraints. At Shapeshift, we believe the future of wearables is 3D printing and custom fitting, because it really allows company to differentiate through 3D printing, with using its free complexity. And you can also, with 3D printing, again, use a free one-off advantage to bring the added value of custom fitting at the same time. Thank you very much.
Thanks, Jonathan. Hey, everybody, if you want to ask Jonathan questions right now, after every speaker, we'll have a couple of minutes for that. So if you can enter your questions in a Q&A box. So Jonathan, I do have a question. It sounds like your software is mostly focusing on the design part of this customization process. What about the material consideration? I mean, do you take in consideration of the machines different kinds of machines out there? And
Absolutely. The way we don't do it ourselves. We work with our customer, which are the company, the brand, the manufacturers, and we will work with their engineers, their designers. We'll make sure that we work end in end to, if they tell us this wall has to be 4.5 millimeter, even after the customization, we'll guarantee that it's 4.5 millimeter. So we work end in end, make sure that we understand the different constraints to make sure that the product, once customized, respect exactly the SOW, the different requirements for that product to be qualifying product from. We don't do FEA ourselves. We do have partner in which if the customer wants to do simulation on each product to certify each product individually in terms of force, we do have different partners which we integrate with to do that automatically.
And how much time do you think like a typical orthotics, prosthetics case, like just use the example on your shelf in the back, like to design that in a current conventional way versus using your software, like how much time are we talking about here?
Absolutely. Different example between, I've seen some workflow for that knee brace, for example, used to take 4 hours. We can do it in minutes, 4 minutes, 3 minutes. The AFO, sometimes it's a matter of 2 days of work by a single technician, the technician that created the product on a CAD software, which know the pipeline by heart, still can take 2 days because the chamfer won't generate. There's robustness issue every time you change a parameter. We do it in minutes.
Okay. All right. So we have one question from the audience here from Shibo. I'm hoping, okay, your name is Shibogai, and greetings. Do you guys use any free open source software?
Like any modern software, inside our core technology, there are open source software. So the answer is yes, but every algorithm, every approach is really unique. We don't like base ourselves of a core, like say Rhino 3D or Blender or stuff like that.
Yeah. Another question, and there's one anonymous attendee who had asked like 4 questions. But let me just start with Paul because he only asked one question. He says, all black, is black the only color in Orthotics?
It's just a matter of branding.
Okay.
Of course, so with HP printers, nowadays you can have like multiple color on the export file, no problem. But yeah, it's our branding.
Yeah, I'm finally digesting the questions from anonymous attendee. I think that these questions are also good for other panelists, some of them. But I'll pick a couple. One is how many podiatrists or
just to date
are using the technology for custom orthotics, basically.
I think so far we've customized, just to give you a sense of perspective, more than 20,000 product using our technology. The number of user, it's not something that we monitor. It's more of the number of order that goes through our system.
Okay.
But we have more than 20 customers around the world at the moment.
Okay. Awesome. Okay, and then okay, I'm gonna save the other questions for later. And then Louis has a question: what is a safety? Like, what is your safety process? So
absolutely. So again, we don't produce the product ourselves. We're not the owner of the IP of the physical product. We help companies which will have their own engineering department, which will have their own design department to automate their process. So they are in charge of the safety. They are in charge of the clinical work of the product. We just help them scale the production to a point that wasn't possible before.
Okay. Do you guys sell the software to clinicians?
I would say that for now, 100% of our customers have been central fab or large group of clinics which have the central technical fab. There's no current clinician that uses the software directly. Okay,
great. So yeah, we have a lot of questions now. Like the floodgate just opened, and but I don't want to keep our other speakers waiting. There are some questions that are really good here. I'm saving it for later. So I want to move on to our next speaker, who is Jeff Chan. Jeff right now is the senior engineer for Verum and also Canadian. He's also a podcast host for Between Two Printers. I love that title, by the way, Jeff. So I'm gonna let you take away.
All right. Advance apologies, I don't have nearly as many graphics as Jonathan did, so hopefully I don't put anyone to sleep here, but we'll move along anyhow. I needed to come up with a title, or at least I felt that I did, for my section of the presentation, and came up with Taking Advantage of CAD and Additive Manufacture for Things That Are Tough or Impractical to Impossible to Do Conventionally. I wanted to come up with the wordiest possible title, and I think I may have succeeded. I just wanted to talk about processes that will make things easier or better with 3D printing rather than just what 3D printing can do. I'm all about the practicality of doing things to make them useful and scalable. So while we often see stories about some guy who did a thing with 3D printing to fit some need for only $15, those stories often neglect to mention that that guy had access to and experience with hundreds of thousands of dollars of software and equipment, including scanners and printers. I prefer to focus on how the technology can be fused to affect as much change as possible. Sometimes that's boring, but somebody has to be boring and practical. So who's Vorum? For those unfamiliar with us, we're the original CAD/CAM solution for the O&P market. This is all we do and all we have done for the last 30 years. We make systems tailored to what O&P professionals need that are easy enough that you don't need to be an engineer or a really technically minded operator. So the better we do our job as a company, the less I'm needed. Oops. Who am I? Per by bio, I'm an engineer. I've worked in